All right, welcome to section 5.2, integers. They want to remind us that the natural numbers are I shouldn't have written it that way, is the set 1, 2, 3, 4, and so on. Well, the whole numbers, and when I used to think about this, I thought about the O in whole, because the difference between the natural numbers and the whole numbers is that we include 0. So it's 0 in the natural numbers. So if you can think about the O and the 0, that's the difference. Well, then if you get the opposites of those, you get the integers. So if we can start ... and then do -3, -2, -1. Think about how they are on the number line. And then the rest of those natural numbers. That way, these are the integers. No decimals, no fractions, just positive and negative whole numbers. So you have your negative integers and your positive integers. 0 is neither. So first off, we're going to talk about inequalities. Prefix in means not, so these are not equal. You have greater than, and then you have less than. And I feel like people know how to answer questions using these, but they don't always know how to read them. So if you feel like you're a little tripped up sometimes with reading them, this less than looks like a capital L. So that symbol and the capital L look alike, so that's the less than. And this other one is the greater than. So if you're going to answer questions with inequalities like 8 and 15, then you know 8 is less than 15. And you might have, I'm so old that we did Pac-Man, but you might have done alligators or something to where something was eating the bigger number. But it was a little trickier sometimes if it was negatives. It wasn't so bad if it was a negative and a positive. We know the positive is always greater, like that. But where it would sometimes get tricky is if it was 2 negatives and you were not quite sure which one was the bigger one. You can either think that negatives are opposite, so -3 is actually larger than -5, or you can think about them on the number line. I think I've told y'all before how I'm one of the worst chart makers or anything like that. So you can find them on the number line. And we get larger as we go from left to right. These numbers get larger in this direction. So since the -3 is further right, it's the larger number. So it's greater than. So you have some problems where you do that. And then we are going to add integers. And I really wish we were in the same room, because I would love to see if you remembered any of the rules or any of the ways that you first learned. So I'm just going to do one example of one way you might have learned. If you had 4 plus -6, you might have had 4 little positive markers, and then you might have had 6 little negative markers. And then you might have physically taken 2 of them, a positive and a negative, and zeroed it out. So you might have said, oh, that positive and that negative are gone. They make 0. Oh, these make 0. Oh, we got another 0. And we got another 0. So what's left is 2 negatives. And that might be how you started out learning about it. I would just love to hear, maybe in class you can tell me. Another way is that you might start out on the number line. And you would start at your 4, and then you're going to make 6 hops in the negative direction. So you go 1, 2, 3, 4, 5, 6, and that's how you land at your -2. Maybe you can tell me, Wednesday, what you remember. So when you add integers, when you add same signs, you add and keep the sign. When you have different signs, you subtract and keep the sign of the larger. But it wasn't actually a larger number, it was the number that had the greater absolute value. So when we did the 4 plus the -6, we subtracted and got 2, and we'd keep the sign of the 6 because it's bigger, in quotes, because its absolute value is bigger. Okay, subtracting, you probably, when you very first started out, you probably did the keep, change, flip thing. So instead of doing 4 minus 8, you probably did 4 plus a -8. So you probably changed this to addition, and you changed or flipped the sign of the second number. And then you follow addition rules. These signs are different, so we subtract them. We keep the sign of the bigger. What if you had -3 minus -6? They do a parenthesis, just they feel like it's less confusing than having it like this. I don't mind either way. So if we keep, change, flip, we keep, change to addition, and flip that sign, then we subtract and keep the sign of the biggest. Or sometimes you were taught if you had those two signs there, they actually came together and made a big positive like that. So again, I'd love to hear what you remember. Then there's one more thing on the number line that you could do. Whoops. So let's say we had -4 minus a -3. Well, we start out at -4. And then I guess we still change, keep, change, flip. So then we go 1, 2, 3, and we'd end up right here. So I don't want to take any more of your time, because I know you've been adding and subtracting and multiplying, dividing for a long time. So probably you would do keep, change, flip if you were doing subtraction by hand, which I am asking y'all to do. And then multiplying and dividing are nicer, just like multiplying and dividing fractions are nicer. So when we multiply and divide integers, it's only 2 rules that work for both. If you have the same signs, you get a positive. And if you have different signs, you get a negative. So I am asking you all to try these without your calculators. But if the numbers are too big or something, you can use them. But try your signs. because we don't use it often. We get a little too dependent on the calculator sometimes. So last example, if you've got -3 times +5, my signs are different, so I immediately get a negative. And you might remember that the difference of two numbers meant that you subtracted them. So it's all kind of related. And if you have -18 divided by -2, the signs are the same, so we get a positive. Okay, I'll see you on Wednesday.